Yo, what's going on, guys? Today we're doing the SSRF, or the server-side request forgery box. Basically, this is just to continue our junior pen testing path, and this is the next one up. So we're going to keep going with this path, and I think it's doing well, and I like it. So here we go. So this one should make a lot more sense to you guys if you guys looked at my one yesterday, the local file inclusion box. It's similar, but it's not the same. So the local file inclusion is basically using those URL parameters to point to a file. This one's kind of pointing, you can use it to point to URLs and things. So it's similar, but not the same. And you guys will see that here coming up. All right, so first things first, what is server-side request forgery? And it tells you that's what it stands for. So there's two types. There's the one that's they're showing here, which they show here, which is the one where you're going to actually see it happen. And then there's blind SSRF. So what blind means is basically you're not going to see anything pop up on your screen. It's happening in the background. So you're not 100% sure. You need to be 100% sure, that it's doing what you think it's doing. Okay. So what's the impact? And it tells you here basically what it can do, and that is it can access unauthorized areas, access customer data, ability to scale to new networks, and reveal tokens and credentials. So that's pretty obvious. So what does SSRF stand for? Server-side request forgery. Easy. Okay, as opposed to a regular SSRF, what is the other type? And that's blind. And again, that's just where you're not seeing anything pop up on your screen. It's just happening in the background. All right, so this one, they do a good job of showing you what you're looking for here. So it says here we're going to take you through some sample SSRF attacks and explain how they work. At the end of the examples, you'll have to figure one out for yourself. Perfect. All right, so here, this is kind of them showing you what's expected. So what that means is if you ever see a URL like this where it says the regular URL and then it points to a URL, that's where it's grabbing a resource for that web page. And that's where we're going to try and change this to something we want and see if it'll give it to us. All right. And this here is showing basically that this is the expected request, the item ID 123, and the hacker actually put in a directory traversal. So he put in //user. So to go back a directory and then go into the user directory. And you can see here that the website request sends out that rather than this item ID. So it actually allows him to traverse those directories without having to actually do much, really. Just change the URL. All right, so here, this is kind of a neat little trick, and you can see they're kind of talking about this and x equals. So what this is they're putting it on the end of their actual request. And what that does is it says, ignore the rest of my requests. So what will happen is basically these sites will put an appendage or append, so they'll add stuff to the end of the site of the URL after the request is made to say, okay, go to this site plus this. And it's a way to basically ensure that you're not going somewhere you're not supposed to, because they've added what's needed on the end to get to the resource that's required by the site. Now, what happens is you can actually put this and x equals, and it will say, stop right there, just do this part of the request. Now, this is important because and I'll show you here in the example. So the example uses that request, and I'll show you guys that. So here, this is the expected request, and you can see this is, I think this is a blind one. Let's see. Okay, nope, that's not what they're doing here. So you can see what they're doing is they're actually he's requesting hacker domain.thm, and you can see the expected request was this, and you can see it didn't actually work, but what happened is he did get information from the hacker domain instead of the API.website. So it didn't actually access the site that they wanted. He actually accessed the hacker domain. So it did go out and reach out, but it didn't actually access any of the backend resources. So what this is this just another way to use this, but it's not actually diving deeper into their network the way that the other attacks were. He's actually doing something totally different. And it says here, the attacker can instead force the web server to request a server of the attacker's choice. So again, all he's doing here is he's using his own web server, sending the information to it, And the reason for that is because it'll capture information about the web server that sent it to him. So you can actually get a little bit more detailed information, and that's all he's doing. He's directing it to himself, so that way he gathers a little bit more information. All right. So here they're telling us, use what you've learned, try changing the address in the browser below to force the web server to return data from this. Okay. So this, they do a really good job. It says to make things easier, down here they'll show you under server requesting, they'll show you what it's requesting. So if we hit enter real quick to see it, okay, we see that it's requesting API first.website.thm. Okay, well, server equals API. So first thing we need to do, because we need it to equals, or we need it to request from server. So we'll say server right there. That's the first thing we're going to do, right? Now let's hit enter. Okay, it says not found, but look, we need to get it to say this, basically, right? So it says here, https server.website.thm/API/item ID equals 2. Okay, so let's get rid of this item. Let's hit enter here. Looks like we just took over area on New World. All right, so what did I do? I'm gonna reset this because I got distracted. All right, so what we're gonna do is we need to get rid of basically that, or we need to keep that item too. It doesn't really matter because what we're gonna do is, you notice it's on the end. That's what we're doing. Sorry guys, I got distracted when that popped up. So what we need to do is we need to get rid of that API item ID, right? Because we don't need that anymore. So what we're going to do is we're going to say server.website.thm, and we're going to do the flag ID equals 9. Now if we hit enter here, you can see what's happening, okay? It's requesting from what we want, but then after that, it's being appended in adding this website.thm API, blah, 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 right? Well, we knew how to break that. They already told us it's and equals, or and x equals, right? So if we hit enter, boom, and you notice it's still requesting from the same thing, but the and x equals stops it from asking for this information. So it actually stops where we want it, which is that flag. So now we can go ahead and throw that flag in here. Whoops. And it's SSRF master. Boom. We're masters of our own domain. Let's get it. Perfect. Okay, so that's a good example, because what happens if it just keeps changing it to this? It keeps adding that. Well, that's a way to break it. Now, it's not going to work every time, I'll tell you that. There are checks against it, but it's good to see. All right. So now here it's showing us potential SSRF vulnerabilities and how they can be spotted. So this is good information here. So obviously we've seen this. If there's a full URL in the URL parameter like this, so if there's a URL and it says server equals URL equals whatever, that's pretty obvious that we might be able to change that and see what happens. Hidden field form. So if you look at the source code of a website and there's a value and then there's a full website in there, we probably can change it, right? A partial URL, so again, if it's server equals API, that's a callback to some sort of API somewhere, so that can probably be changed, right? Which is what we just did, which is the server.api, that we just changed it to whatever server we wanted. And then here's the other one, or perhaps only the path of the URL. So if there's a destination, forms, contact, whatever, again, this is an example that you may be able to change that and possibly traverse through their network as well. Now again, don't do this on a regular website, because this is, again, illegal. So what I mean by that is, we've done some of the previous boxes where it's public information, you're doing Google dorking, stuff like that. That's public, it's not illegal. This is illegal. You're trying to access unauthorized access, so that is illegal. All right, so here it tells us, if working with a blind SSRF where no output is reflected back to you, you'll need to use an external HTTP logging tool to monitor requests. So what that means is, it'll need something that is actually capturing what's happening, so that way you can view it rather than getting that direct feedback. So it says requests such as requestbin.com lets you use your own HTTP server or Burp Suite. You can use any of those. So it's asking us here what it is looking for, and it's requestbin.com. Boom, we got it. Again, those are just examples of ways that you can use a HTTP logging tool to watch what's happening. Okay. All right. So now, this one, more security savvy developers are aware of this vulnerability and may put in checks. Okay, that's obvious. We know that, right? So what are some of the checks that they might put in? Well, they might put a deny list in. A deny list is where all the requests are accepted except for resources from a specific list. So what resources might they block? That might be local hosts. So 127.0.0.1 would appear on a deny list. So the reason for this is basically it can't request to see its own stuff. Makes sense, right? It's what it's trying to do is protect that endpoint. So what that means is if the request is coming from the local machine, you're trying to access the endpoint server, it's going to deny that because the server will never ask for its own address, right? So they know that's probably something that's trying to gather information. So it tells you how can you bypass this. Well, you can use different IPs such as 000, all zeros, 127.1, all these, everyone knows these. Or you can use subdomains that have a DNS record which resolves to the IP address 127.0.0.1. So what that means is if the DNS record, let's say you have a DNS record in there for 127.0.0.1, so some people might put that in there so you don't have to type it in, something like that. If it has that DNS record, you can just use the DNS record rather than the actual IP. Okay, so then it says here in a cloud environment, it's beneficial to block the 169.254, 169.254. Reason because this contains metadata deployed to the cloud server, which could be dangerous for an attacker to have. Okay, so again, how can they beat this? Registering a subdomain on their own domain with the DNS record. So again, that way it's looking for a DNS record, not for the IP. All right, so we're moving on to the allow list. An allow list is just the opposite. It allows every access gets denied except for what you're allowing. So the deny list denies specific things. The allow list allows specific things. That's simple. Such as a rule that a URL-based parameter must begin with this. So again, how can they prevent it? Let's say they make it where if you're going to request something, it has to begin with website.thm so that they know it comes from their website, right? Makes sense. But how can we beat that? Well, that's pretty easy. We could register a domain on their domain. So we could get basically a subdomain. So ours would look like this, https website.thm, which this needs, but then .attackers.domain. Okay, so that's pretty common. A lot of places have subdomains. Some places even let you create your own using theirs, so it'd be even easier to do, right? So that's just ideas that they're telling you that is possible to beat. So again, don't try that. Just know that it exists. You can try it on boxes like this. All right, it says if the above does not work, there is one more trick up the attacker's sleeve, and that's the open redirect. So the open redirect is an endpoint on the server where the website visitor gets automatically redirected. So you'll see this a lot of times in source code or in anything like this. So this is a perfect example. HTTPS. So if you ever see like where people change the links and stuff, this is a good example of why they do it. What this does is it's website.thm and then it redirects you to try hack me. Now the reason they do this is for marketing purposes, it says, so that they can see how many times someone clicked on the link. So this website.thm tracks how many times that link's been clicked so they can see, where's the market is hot, where they're getting good information, who's clicking on it, that type of stuff. It tracks that information and then takes you to the tryhackme.com lab. So again, these redirects are used for legitimate purposes, but you can use them to redirect yourself to wherever you want, right? Because now, so it's like it says here, so take example, that link specifically, it was made to record the amount of clicks, cool, but imagine there's potential SSRF vulnerability, which only allows URLs beginning with the website.thm. So again, let's say you have that where it only allows websites that start with that specific domain. Well, you could just redirect it and use this first part. So you could just say, okay, https website.thm, and then redirect to whatever you want, and it's going to say, okay, that's good because it starts with website.thm. So pretty easy. What method can be used to bypass strict rules? And it looks like that's probably going to be the open redirect. Boom. What IP address may contain sensitive data in a cloud environment? 169.254, 169.254. And that's going to contain the metadata for the domain or company or whatever they have set up. Okay, what type of list is used to permit only certain input? So this is asking which one is used to permit only certain input. So that would be the allow list. And then what type is used to stop certain input? Obviously the deny list. And that's pretty self-explanatory, right? All right. So now we're moving on to the SSRF practical. So this is where you get a little bit nitty-gritty with it, and it's a lot of fun. All right. So it tells us first things first. We're trying to get the private. That's basically our flag we're trying to capture. So what it's showing us is if you go to it, which we can go to it here, but basically it says you'll get an error explaining that cannot be viewed from our IP address. Okay, cool. So again, it's just saying that access is denied. The second is a new version of the customer account page. Okay, so this is where we need to make an account. So let's make our account stuffy1234, email address stuffy1234 at mail.com, password stuffy. All right. So we're logged in. We've got it. And if you're doing web penetration testing like this, you're going to do a dirbuster, gobuster type of directory listing. So when that happens, you're going to find this anyway. So they're saying there's a actual field called customers, new account page, and this page isn't ready for publishing yet. They have it hidden. It's not actually advertised on there. And what it does is it lets you select this avatar. So they're still working on it, is what's happening, right? But the problem with that is, again, if we try and do discovery on this site, we're going to find that. So perfect. Let's see what we got. All right, so they're telling us to look at the source code of the avatar specifically. So we'll go here and we'll just go to inspect. We'll move this up a little bit so it's a little bigger. All right, so what we're doing is we're looking for the actual avatars. Okay, so if you can see here, each one of these is its own avatar. We're using this one here specifically is what we're looking at. And we'll look at this. Okay, so input type. Okay, so I see the URL there. And the value is assets avatar 4.png. So that's interesting. That's the path it's taking. So what if we try to change that? What if we edit that? Okay. What if we edit it and say, instead of this value, we want to go to private. And then we select it and we hit update. What do we get? Okay, well, we got, looks like nothing. Looks like nothing happened. Yeah, we didn't get anything for that. Looks like nothing's going on. If we look at, if we find our current avatar, doesn't look like we got any information out of that. So that's interesting. And they're doing it a little bit different over here on ours. They're actually showing you that there will be an error, I believe. URL cannot start with private is the URL you get, apparently. Let's see what happens. Okay. I'm just looking to see what method they're using to get the error message. If you choose one of the avatars, click to update, you'll see the form change, and above it display your currently selected avatar. Okay, so what it is they're saying it's going to be right there. So our currently selected avatar, which is right here. And you can see here, there is data in it, but it's base 64 encoded. So let's go ahead and decode that. Well, maybe I'll have to edit it, I guess, just to copy it. Okay, so we have a whole bunch of information here, but what did we get out of it? Anything, I wonder? So we'll go here. We'll go all the way down. Whoops. And we'll copy that, and we'll go to our Cyber Chef. And we'll see if this gives us anything. It might not give us anything. From base 64. And you can see it didn't really give us anything, just a bunch of junk information. So we know that didn't work, right? That's not what we wanted. We didn't want, there's no way that's the contents of private, right? There's a lot more information there than I thought, I guess. All right. There we go. Okay. So now we'll go back over. We'll try something else. So the reason this might have happened is, and you'll see here, they got this error, URL cannot start with /private. Okay, cool. So we know that it can't start with private. So what can we do to get around that? Well, they kind of show you a cool trick here, and I'll show you this. What they're doing, and we're going to change our avatar to this one here. So make sure I get the right one right there. All right, so number 5 here. All right, so what we're going to do is we're going to change this, and we're going to edit as HTML. And we're actually going to do the same, something similar, but a little bit different. We're going to do X, then / then private. Now, what this does is pretty obvious. It takes away the URL cannot start with / private, right? And it starts it with this X, and then it goes back a directory and back into private. So it's basically, or it goes up a directory, excuse me, then into private. So all we're doing is changing the format that it's recognizing, so that way, if it is going to give it to us, we don't have to worry too much about. All right, so we've got it set about getting busted on it. Now we update our avatar. Okay, we got new avatar updated. Let's see it. Okay, current avatar is not showing for some reason, but that's all right. Okay, so let's see if we can find our current avatar in here. I don't know why it did it this way, but whatever. Boom, boom, boom. Come on. Okay, so there's the post, new account page. Okay, so we got the avatar updated, so that's actually good. Now, I would like to look at the current avatar, but there is no... I want to inspect that specific element. There it is. Okay, so it's just not showing up as a picture, which it shouldn't, right? Because we changed the file. So that's a good indication that it might have worked. So now, if we edit as HTML, we notice we have a much smaller base 64 input here. So that leads me to believe that might be a flag. All right, I'm trying to see if the quote. All right, so let's copy that, go back here, and we know it's base 64 encoded, and boom, there's our flag. So what that tells us is this is the contents of that private folder that we got just by using that little neat trick of changing the directory name in from private to X / and then back a directory and then forward a directory. Now, the reason that we did that is simple. It's specifically looking for you to do that, or to accidentally type in the private, or it's specifically told to deny any request for private. So if you remember, that would be on the deny list, that if anyone types that private. So we just tricked it into thinking we're not typing private, and boom, there is our box. It's that easy, guys. This one was a lot of fun. I think this one teaches you a lot, and it's very cool to be able to do that, right? Because there's different ways of doing it. The way they edited the code, they got the errors directly in front of them. The way I edited the code, you would have to actually go through the code to find the errors. I did it simply because this is the way I enjoy doing it. You guys can do it the way they do it, which is edit the whole page source and submit it. But either way, guys, this is a lot of fun. I'm going to keep trying to do these. Hopefully you guys like them. And one thing I noticed just messing around is I've noticed there isn't any guides for any of this stuff. So hopefully I can be one of the first people to get these guides out here. And then the whole path, you guys can learn it with me. So hopefully you guys like it. If you guys are enjoying it, make sure you hit the like. We're almost at 100 subs. So if you guys can sub, that'd be awesome. We've got, I think, 95 now. So hopefully we can keep this train going. And let's just all learn together, guys.